In order to demonstrate some Hive queries, I've gone back into my virtual machine from Cloudera, and you can see I'm running the Hue browser. So to set this up, you're going to want to go into the examples, and then you're going to want to just click on this all to install all the application examples, or you can install individual ones. And once you do that, if you click Home, then you'll see you have a number of query editors, and they include Hive, Impala, which is the in-memory, and Pig, we've talked about those, as well as the job designer to run MapReduce jobs. So if we just wanted to take a look at the Hive queries, we click on Hive. And again, it makes it really, really simple because Cloudera has given you some examples. They've populated some HBase tables, and they have loaded the Hive libraries and started the Hive service. So let's first take a look at the sample tables. So we've got sample 7 and sample 8. So if I click on sample 7, I can see that it's a very simple table when I have 2 strings and 2 ints, and sample 8 is very similar. And if I wanted to examine it further, I just click on here, and I can now see it in the Hive Metastore browser. And you can see here's the metadata, and then I can see a sample of the data, and I can see the properties of the data here as well. So this is a graphical viewer of the Metastore for Hive. So you can see I have the ability to import data, browse data, drop table, or view the file location. So if I click on Import Data, I can then import data from my file system. So if I wanted to do that, just click on here, and I can upload a file. It just makes it really, really easy. And I can upload it from my desktop. And again, I'm on my virtual machine here. If I click on View File Location, it shows me that this particular data is located at this particular location. Now, it's interesting because you might remember with Hadoop, you have 2 different file systems. You have the regular file system, in this case, this is the Linux file system, and then you have the HDFS file system. So if you're ever confused about which one is where, you can see that this is on the Linux file system because it starts with user. Okay, so I'm going to go over here to the file browser, and you can see this file browser is for the HDFS file system, which sits on top of the Linux file system. So I'm going to go here, and you can see that here I'm inside of the HDFS file system. So here's HDFS, and I can browse through here, and I can take a look at the different things that are here. Let's actually verify that this is on the regular file system. I could have misspoken there. Let me take a look. That's what this thing is really for, right? So I'm going to Hive and this folder. Okay, so this is on the HDFS file system. I was thinking that was the case because it's inside of here. So again, it's very tricky, as you can tell, and that's why I like to use this file browser rather than just using the file system file browser. Because again, this is a very common mistake when you first start, because you'll start with placing your files on the regular file system, and then you'll load them into the HDFS file system. That's what you're doing when you, and let me go back over here and click again on the data and on the metadata browser. So to be clear, when you say import, what you are doing is you're importing from your Linux file system into the HDFS file system, which is an abstraction layer that sits on top. As I work with new users, I often see them, they can't find their files. So it may seem silly, but it's a really good differentiation to be aware of when you're first working. And again, I'll remind you that when you're working with the Hadoop processing, you can run MapReduce, which of course includes Hive, because it's an abstraction over MapReduce, against the regular file system. There's no requirement that the source files that you MapReduce against are in HDFS. That's a great flexibility of Hadoop itself. The files can be in a local file system, or as I often find with customers who are storing data on the cloud, such as Amazon, they'll actually run MapReduce against S3 rather than HDFS because they really don't want the triple replication. So it's an important point when you're doing queries. Where is the source data, and do you need to load it into HDFS for that triple replication of the data and the self-healing retry of the queries? But let me go back over here and let's run a Hive query. So let's run one of our samples. I think there's some samples here. So I'm just clicking back over here. So I'm just going to say this one, which is top salary 2007 above $100,000. And again, I just want to point out, It's really important takeaway from this course that you use the right tool for the right type of query. You see how these are simple aggregates? This is pick a value. This is sort the values of a filter. And this is filter and then retrieve values. It is not manipulate the underlying data by cleaning it. So something I see done incorrectly by a lot of customers. They think it's just a one-stop shop. They think that they can just use Hive for every sort of data manipulation because, again, they're comparing with ANSI SQL. And Hive is a subset designed for a very specific set of problems. So let's just read this query and make sure we understand it. Select this value from this table, and notice how the syntax is opposite of what we're used to. This is the table. This is the column, if you will, where the salary is greater than. So this is your filter. Order by the salary and take the top 1,000 of them. So we're first going to execute this. And now we're going to take a look at the execution process. So here we can see we're already working with reducers. And here we have a job ID, and here it's starting. We have one mapper and one reducer. This is an interesting message. Apache.hadoop.mapRed is deprecated. Use hadoop.mapreduce.taskCount. And you might remember from the section on MapReduce that MapRed is MapReduce 1 and MapReduce is MapReduce 2 or yarn. So you're going to see a lot of that as the Hadoop ecosystem transitions to MapReduce 2. So here we're seeing process, and then we're seeing results. So you might have been surprised that to get 1,000 results, it took, maybe 15, 20 seconds. Because again, this is a batch type of a process. And now we can also run the explain, which will show us the execution path. And let's just start with the map. So the map did a table scan, tells us how big it scanned. Then it did a filter. It tells us about the statistics, because you might remember from an earlier movie that you can do cost-based optimization now on statistics, kind of a lightweight indexing, if you will. And then we have the reduce operator tree. And then we have the fetch. So these are the various processes. Now, I believe as the Hadoop ecosystem matures, having worked in the relational ecosystem for many, many years, that these text-based query plans will probably benefit from having some graphical tooling just to make them a little easier to work with and some hinting and suggesting, like the query optimizers we're used to on, say, SQL Server. But for right now, this is really what we get. So let's just run one more Hive query so that we can have a basis for comparison here. So we looked at top salary. Let's look at job loss. So again, we've got select some values. Here we've got a join. So we're joining these two tables. And we've got our join column. And then here we have a condition and another filter. And then we order by and limit. So let's run this. And let's take a look at the execution plan again. And you can always tell that it's really getting to the point of starting when you see the map and the reduce here. Now again, I'll remind you that this VM is running in pseudo-distributed mode, which is having an HDFS volume on one drive and all the Hadoop daemons on one particular machine. This is adequate for POC kind of testing, and here's the results. But for anything that you're going to move to production, you want to use a more robust kind of cluster. What I usually use is I use a cloud-based implementation. Most often I use Amazon, as I showed in an earlier movie, with spot pricing, because I find that's a really cheap way to do it, as long as you remember to turn it off. And again, I'm just going to click explain. So you can see, again, this is a join, and it doesn't look anything like relational. Again, I'm not really going to go into the detail of this other than to say it's really important for you to, if you're going to try to run join Hive queries with large amounts of data, to performance test them with something that is close to production levels of data. And again, I use Amazon for this quite frequently because it's really good to just spin up something, put a bunch of data in it, do spot pricing, see how it really works. Because although this looks like ANSI SQL, you don't want to be surprised when you deploy this into production.